Problem number 12. Find the z-transform of x of n, which is 0.2 to the n, 5 to the n times u of n minus 2. And also show the region of convergence. One is right-sided and the other is left-sided. Therefore, we call it two-sided. We have two different sides, one left and right. Therefore, two-sided signal are bilateral signal. These are just two different names. Whether you call it two-sided or bilateral, bi means two. It is one thing. To find the z-transform, we're going to plug in the value of x of n in the equation of the z-transform, which is x of z equals to summation of 0.2 to the n, 5 to the n into n minus 2 into 0 to the negative n, which starts from negative infinity up to positive infinity. We need two-sided z-transform. It is the equation of the two-sided z-transform or the bilateral z-transform. So for the x of n, we plugged this expression because my x of n equals to this. So just plug in that expression here for the x of n. Now look, we have two different sequences. One is the right-sided sequence and the other is the left-sided sequence. So for the right-sided, we're going to use the right-sided equation. For the left, we're going to use the left-sided equation. For the left-sided sequence, we must have negative in front of 5, which equals to summation of 0.2 to the n times z to the negative n, where n starts from 0 up to positive infinity, minus summation of 5 to the negative n times z to the positive n, where n starts from n equals to 2 up to n equals to infinity. Look what I did. You just have to interchange the values for the n with the opposite sign. This part goes up and the upper part goes down with opposite signs. From negative infinity it becomes positive here, so I will have n equals to positive infinity, and this from negative it becomes positive. I will have n equals to positive 2 here. Similarly, we're going to change the sign of the power of 5 and also the power of n. From positive n it becomes negative n, from negative n it becomes positive n. Therefore, I have n equals to positive infinity and n equals to 2. We interchange the values of n with opposite sign. Similarly, from positive n it becomes 5 to the negative n. From negative n it becomes positive n here, z to the positive n. So I can write summation of 0.2 times z to the negative 1 to the whole n. I just wrote 0.2 to the n times z to the negative n equals to 0.2 times z to the negative 1 to the whole n. When you apply the power, you will get back the same thing. Similarly, we know that to find the z-transform, we must have 0 here. We are on the way towards the right-sided equation. But the difference is that we have positive 2 here. If we have n equals to 0 up to n equals to infinity, then we can find the z-transform. To do so, we're going to put n equals to 0. So I will have 1 minus summation of 5 to the negative 1 times z to the whole n, where n starts from 0 up to positive infinity. But where this 1 come? This 1 comes when we plug in n equals to 0. N equals to 0 here, n equals to 0 here. So I will have 5 to the 0 times z to the 0. 5 to the 0 is 1 times z to the 0 is 1. So 1 times 1 will be 1. Therefore, by plugging the value of n equals to 0, I have 1 and then minus summation of 5 to the negative n times z to the whole n, where n starts from 0 up to positive infinity. It is because when I plugged n equals to 0 here and n equals to 0 here, now my lower limit is n equals to 0. It is no more n equals to 2. So from here we have shifted into 1 minus summation of 5 to the negative 1 times z to the whole n with n equals to 0 up to infinity. Look, I just wrote 5 to the negative n times z to the positive n equals to 5 to the negative 1 times z to the whole n. When you apply the power, you will get back the same 5 to the negative n times z to the positive n. So it equals to 1 over 1 minus 0.2 times z to the negative 1 minus 1 minus 1 over 1 minus 5 to the negative 1 times z. Whatever stuff you have inside the parentheses, you're going to plug in here. Whatever stuff you have inside the parentheses, you're going to plug in here. Now, can I write 5 to the negative 1 equals to 1 over 5 and z to the negative 1 equals to 1 over z? When you write z to the negative 1 equals to 1 over z, you will get 0.2 over z. And also after writing 5 to the negative 1 equals to 1 over 5, I got z over 5. Now to take the LCM of these two terms and LCM of these two terms, we just took the LCM of these two terms to get z minus 0.2 over z, and also the LCM of these two terms. Now to bring this z up to the numerator and bring this 5 up to the numerator here. It equals to z over z minus 0.2 minus z over z minus 5. Look, this z goes up to the numerator and this 5 goes up to the numerator here for the right side. And then we're going to take the LCM of 1 minus 5 over 5 minus z. So the right term will be 5 over 5 minus z. When you take the LCM of negative 5 over 5 minus z with the 1, you will get z over z minus 5. I have negative here, which implies that x of z equals to z into z minus 5 minus z into z minus 0.2 all over z minus 0.2 into z minus 5. Just take the LCM of these two terms, you will get this kind of expression. You can do further simplification, but for timing this is my z transform. What about the region of convergence? Let me check the region of convergence in the complex z-plane. This is going to be the region of convergence in the complex z-plane, where z modulus must be less than 5 and z modulus must be greater than 0.2. So for the region of convergence, I can write that z modulus must be greater than 0.2 and less than 5. Now when you compare this problem with the previous one, with problem number 11, there's a big difference. Here we are dealing with the two-sided infinite sequence, the bilateral infinite sequence, not the one-sided. Last time we had the subtraction of the one-sided, the right-sided sequences. But here we have the addition of the two different sequences. One is the right-sided and the other is left-sided. Therefore, the region of convergence for the two-sided sequence will be in this shape. It is a ring shape. It is an annular shape. We are pretty much familiar that what kind of region of convergence we're going to put for the two-sided Z transform. If you remember last time, for the region of convergence, we were taking the longer radius. The longer radius, which is 2, not 0.4. So z modulus must be greater than 2. This was the region of convergence. It happens, remember, it happens only when we have the addition of two one-sided sequences. 2 to the n is a right-sided sequence. 0.4 to the n is also a right-sided sequence. So both the signals are right-sided signals. Therefore, it comes under one-sided or unilateral infinite sequence. Similarly, when you have the addition or the subtraction of both left-sided sequences, you're gonna go for the longer radius. So the two sequences must be same. Like both the signals may be the right-sided sequences, or both the signals may be the left-sided sequences. You cannot go for the longer radius when you have the addition or the subtraction of one right-sided sequence and one left-sided sequence. That comes under two-sided category, not one-sided category, remember. The region of convergence is a ring shape. It is a two-sided sequence, not one-sided sequence. We have the subtraction of one right-sided sequence and one left-sided sequence. Look, its actual form is 0.2 to the n minus into minus 5 to the n into u of n minus 2. Minus times minus becomes positive. So it is the subtraction of one right-sided sequence and left-sided sequence. So both the sequences are different. Therefore, it comes under two-sided or bilateral infinite sequence category. The region of convergence will be the annular region or the ring-shaped region. You cannot go for the longer radius. Look, for the right-sided sequence, the outermost pole is 0.2. So we marked the outermost pole at 0.2. The region of convergence starts onward of 0.2, not lesser. So we must go greater than 0.2. Greater than 0.2, not lesser than 0.2. Lesser than 0.2 is a blank space. The region of convergence does not exist here. Similarly, for the left-sided sequence, we have the innermost pole 5. This is the innermost pole 5. Z modulus must be less than 5. We must go lesser than 5, not greater than 5. Greater than 5 is an empty space. We don't have the region of convergence. This blue is the region of convergence. So the region of convergence comes between 0.2 and 5. But remember, 0.2 and 5 are not included. Pole is not included in the region of convergence. So we can write that z modulus must be greater than 0.2. You have to go greater than 0.2 and must be less than 5. You have to go lesser than 5 here. The ring shape only happens when the right-sided radius is less than the left-sided radius. Only then you will be able to get the ring shape. Look, as I said, pole is not included. If I plug in 0.2 for the z, if z equals to 0.2, 0.2 minus 0.2 will be 0. 0 times anything will be 0. You will get 0 in the denominator, which is undefined. Z transform goes to infinity when you have something of 0. Therefore, you cannot plug in 0.2 for the Z. So we can say that pull is not included. Similarly, you cannot plug in Z equals to 5 here. When you plug in Z equals to 5, you will get 5 minus 5, which equals to 0. So 0 times anything will be 0. You will get 0 in the denominator, which is again undefined situation. Your Z transform goes to infinity, which is not okay for the region of convergence. For the region of convergence, we need something finite. This is the finite outermost pole. This is the finite innermost pole. Now look, as I said, Z transform is an infinite series, but it converges only for the finite sum. We have to shift or change the signal into finite form. That region where the Z transform convergence is called the region of convergence. That's what we did here. We make things finite here. We have this specific region, this blue region, which is the finite region. It does not go to infinity. We contain the things in finite range. This is the finite range from 0.2 to 5. The Z transform converges for the given source signal. So you cannot go for the longer radius, like you cannot take 5. You cannot take that Z modulus must be less than 5. It is not the case for the two-sided sequence. It happens for the one-sided sequence. Here you're going to mention both the finite pole. Z modulus must be greater than 0.2. You have to go greater than 0.2. This region is greater than 0.2 and must be less than 5 modulus. This region comes lesser than 5 modulus.